Hello, welcome to this lecture on modeling, analysis and estimation of three-phase unbalanced power network. We are talking about the derivation of Jacobian matrices. So, we have so far derived J1 and J2. Now, let us look at J3. So, matrix J3. So, J3 submatrix. So, J3 submatrix is actually del P by del theta int, right? P vector we have said, and theta int vector is, we said that it is theta internal 1, theta internal 2, dot 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 theta internal m transpose. So it is m cross 1 vector. So as a result, J3 is 3n cross m, right? It will be 3n cross m. So in our particular case, in 2-bus system, theta internal is actually vector is theta internal 1, right, because m is equal to 1. As m is equal to 1, so there is only one expression. Now in general, if I look at we said that the expression of PIP is, this needs to be looked into. Expression of PIP is L is equal to A, B, C, then J is equal to 1 to n plus m, then it is VIP, VJL, PL, cosine PL. Now this can be written as not del PIP, oh, it's PIP. So this can be written as PIP L is equal to A, B, C, and then J is equal to 1 to n, then VIP, VJL, YIJPL, cosine theta IP minus theta JL minus alpha IJ PL plus L is equal to A, B, C, J is n plus 1 to n plus m, right? Then VIP, VJL, YIJPL, cosine theta IP theta JL minus alpha IJ PL, right. So this we can simply break it down from j is equal to 1 to n and from j is equal to n plus 1 to n plus m. Now these terms are all internal buses. Please note, in our notations these terms are all due to internal buses. In our notations these terms are internal buses, due to internal buses. Because our notation is that if there is n number of buses original, so our internal buses would be numbered as n plus 1, n plus 2, n plus 3 up to n plus m. So, internal bus numbers are, they are actually numbered as n plus 1, n plus 2, n plus m, and etc. Now we know, now we already know that V j A is equal to V j B is equal to V j C is equal to V internal j minus n. V internal j minus n. Now, this is little confusing. For example, where j is varying from n plus 1, n plus 2 to n plus m, and j is varying from n plus 1, n plus 2, n plus m. For example, if I have, and let us first write it, theta j a is equal to theta internal j minus n, theta j b is equal to theta internal j minus n minus 2 pi by 3, and theta j c is theta internal j minus n plus 2 pi by 3. Again, j is varying from n plus 1, n plus 2 to n plus m. For example, illustration, let us do some illustration, otherwise these notations are becoming very confusing. Let us take illustrations. Until unless these notations are clear, then we will not be able to proceed clearly. For example, in the 2 bus system, n is equal to 2, m is equal to 1. So, my theta internal vector is theta internal 1, and we also say that theta 3a is equal to theta internal 1, that I can write as theta internal 1 is 3 minus 2, right. So, here in this case, so this is j, so this value is j. So, I mean j is equal to 3. So, here in this case j is equal to 3 and n is equal to 2. So, then therefore, theta internal 3 minus 2, that is 1. So, it is theta internal 1, that means theta internal 3 minus 2, that is 1. And we know that theta 3b is equal to, I know that theta 3a minus 2 pi by 3. So, that would be theta 3a, we have just now said that it is theta internal 3 minus 2 minus 2 pi by 3. So, this is j and this is n, j minus n, right. So, this is j minus n minus 2 pi by 3. Similarly, theta 3c is equal to theta 3a plus 2 pi by 3 is equal to theta internal 3 minus 2 plus 2 pi by 3, right. So, theta internal 1 plus 2 pi by 3, correct. So, this is the notation. Suppose I do have, suppose, so this is example A. Suppose I do have, suppose on the other case, illustration B also, let illustration B, let n is equal to say 5, m is equal to 3. So, that means my internal buses are, so 5, so they would be 6, 7, 8. Internal buses are 6, 7, 8, right. So, then therefore, here in this case V6A would be, so here in this case V6A, so initial number of buses are n and their m is equal to 3, and these 3 generators are connected at bus 1, bus 2 and bus 3. Bus 1 internal bus, basically the internal bus for generator 1 is denoted as 6, internal bus for generator 2 is denoted as 7, internal bus for generator 3 is denoted as 8. So, V6, so then therefore 6, 7, 8, these are all balanced buses. So, then therefore V6A is equal to V6B is equal to V6C, we denote it as V internal 1 because it is generator 1. Now, what is V internal 1? So, V internal 1 internal, then J is 6, 6 minus 5, right. So, this is J. So, these values are all J. So, this is J, this is J. Similarly, V7A is equal to V7B is equal to V7C because we are taking them as internal buses. So, V internal, we say that this is internal bus corresponding to generator 2 which is connected at bus 2. So, V internal 2. So, this I can write down as V internal 7 minus 5. So, therefore, here as I say that this is n is equal to 5. So, this is J is equal to 7. So, this is J and this is n, right. Similarly, V8A is equal to V8B is equal to V8C is equal to V internal 3. I say that this is V internal 8 minus 5. So, this is my J, this is J, this is N, right. So, and then similarly theta 7A is equal to theta internal 2, right. So, that is nothing but theta internal 7 minus 5. Then theta 7B is equal to theta 7A minus 2 pi by 3 is equal to theta 7 is theta internal 7 minus 5 minus 2 pi by 3, right. So, here in this case as we said that this is J, this is J, this is N, and similarly theta 7C, that is theta 7A plus 2 pi by 3. So, that would be theta internal 7 minus 5 plus 2 pi by 3. So here also this is j, this is j, this is n. So this is the formula, correct? So with these illustrations we can say that these relations hold good. So these relations hold good. So these are the relations. Now with these notations, now let us try to expand this. So L is equal to ABC and J is equal to N plus. Now, so with this, now we will use these notations here. Now if I use these notations here, so what do I get? Now, so then therefore if I use these notations, so if I use these notations, L is equal to A, B, C, J is equal to N plus 1 to N plus M. Then it would be VIP, VJL, YIJPL cosine theta IP minus theta JL minus alpha IJPL. Right. So VIP, VJL, YIGPL cosine theta IP minus theta JL minus alpha IGPL. Now let us use this L is equal to ABC separately. So if I use this L is equal to ABC separately, I get J is equal to N plus 1 to N plus M, VIP, VJA, YIJPA cosine theta IP minus theta JA minus alpha IJPA, that is for L is equal to A, plus VIP, VJB, YIJPB cosine theta IP minus theta JB minus alpha IJPB, right, plus VIP, VJC, YIJPC cosine theta IP right. So if I just separate L is equal to ABC, then I get. So then therefore let us note it down for convenience. So this term is for L is equal to A. This term is for L is equal to B, and this term is for L is equal to C. Now VJA, we said VJ, VJB, VJC is equal to V internal J minus N. So let us use that. So now if I use these expressions, these relations in this, what do I get? So this will be equal to J is equal to N plus 1 to N plus M, VIP, VJA is VJA, we said that it is V internal J minus N. So V internal J minus N, then Y I j p a cosine theta I p minus theta j is, we said that it is theta internal j minus n. So, it is theta internal j minus n minus alpha I j p a. So, this is for the first term. Second term would be VIP. VJB is also equal to V internal j minus n, because these internal buses are considered to be balanced. So, it will be V internal j minus n. Then Y I j p b cosine theta I p minus theta jb, and theta jb we said that it is theta internal j minus n minus, so then minus means this plus 2 pi by 3. So, it would be theta internal j minus n plus 2 pi by 3 minus alpha I j p b, correct. So, this is for the second term, and the third term V I p V internal j minus n, because VJC is also equal to V internal j minus n. Then YIJPC then cosine theta IP minus 2 pi by 3 minus alpha. So, this is the expansion of the second term in this. So, this is the expansion of the second term due to the internal process. So, now if I add them together, so then therefore, expression of PIP, it is L is equal to A, B, C, then J is equal to 1 to N, right. Then VIP, VJL, YIJ, PL cosine theta IP alpha ij PL. So, this is the first term. So, this is the first term what we have already written. Now, for the second term we will use this expression, plus j is equal to n plus 1 to n plus m plus, or rather let us take this plus here, plus j is equal to n plus 1 to n plus m VIP, right, because we are writing for VIP. So, it will be VIP V internal j minus n, V internal j minus n, YIJPA, YIJPA cosine theta ip minus theta internal j minus n minus alpha ijpa minus alpha ijpa, right, plus vip v internal j minus n yijpb yijpb cosine theta ip theta internal j minus n plus 2 pi by 3 with bracket closed minus alpha ij, correct. VIP V internal j minus n yijpb cosine theta ip minus theta internal j minus n plus 2 pi by 3 minus alpha ijpb plus VIP V internal j minus n yijpc cosine theta ip minus theta internal j minus n minus 2 pi by 3 minus alpha ijpc. And all of them are in a very big bracket. So this is the expressions for PIP. So we can simply say that the first double summation term is due to the all the existing original buses, and the last single summation term, basically this single summation term is consisting of 3 separate terms. We have changed phase B, phase C and phase C. So these 3 terms which has got single summation, these are due to the internal buses. So you see, if we look at, so if we compare this with this, so we can now, if I compare with this with, let's say, the expression of P2B, so you see last 3 terms correspond to the internal bus. So this term and this term, they correspond to the internal bus, and the first 6 terms, they correspond to the original buses, right. So the first 6 terms, they correspond to the original buses, and the last 3 terms correspond to the internal buses, and these 3 expressions are exactly in the same general form as we have just now written, are exactly in the same general form as we have written. So this is for n is equal to 2 and m is equal to 1. So because m is equal to 1, so then therefore in this summation, if I put this in this summation, what I will get, n is equal to 2, that is j is equal to 3, and n plus m, that is also is equal to c is equal to 3. So then therefore j would be only varying from 3 to 3. So that means j will have only one value, that is 3. So then therefore corresponding to j is equal to 3, we will have 3 terms. So v internal j minus n is 1, and then etc., etc., right. So these expressions, they give me the general terms including v internal as well as the theta internal. So we will use this general expression along with the expression for this P2B to derive the expressions of J3 and J4, right, in the subsequent lectures. Thank you so much.